So yesterday there was the comment on Twitter about big data conference, small hamburgers. Today it's a big data presentation, small audience, I suppose. Hola, ¿qué tal? That's the only Spanish I speak, and ocho cerveza, of course. So today I'm going to talk about deriving real value out of big data. In my role, I've been involved in big data projects for about 4 years now, and in several European companies, banks, oil drilling companies, insurance companies, industry companies, and what have you. And often the question is, so now I'm embarking on a big data project, so how do I monetize my big data project? And that is what this presentation is about, and also how do I change the culture in my organization to derive value out of the big data. So in this room we'll probably have people with different responsibilities and from different industries, and you probably all have your own definition of how you want to improve the business, like making more sales, driving back costs, finding new opportunities, finding new customers, and so on. And data can definitely help you with that. And to the extent where it is big data, that remains to be seen. But when it comes to data and analytics, we have seen a big explosion of projects and initiatives from companies that really drove value to the organization. And I hope that I can give you some insight into what are the key aspects or the key requirements before you can drive value. So for example, a European customs department, as you can imagine, if you cross the border with a truck and so on, your truck may be searched, your truck may not be searched. So how do you find a truck that needs to be searched? Because searching a truck could be 1, 2, 3 hours of work. And if you want to search every truck that crosses the border in order to find illegal goods or to find illegal people, nowadays is quite popular as well, you will spend a lot of time, and the queues at the border will remain very long. So finding the right indicators, finding the right features in order to determine which trucks to search, which cars to search, and which not, is really important for that borders organization. Another example is the city of Dublin. So the Dublin City Council wanted to improve the traffic in their smallish city. There's a lot of traffic jams. There's a public transport that drives about 100 buses through the city. So how do you know that the buses will take the optimal route? How do you know that when buses are blocked by traffic, when they will be late, and so on? So delivering that information to the people who are riding on these buses is extremely important. So I traveled a lot by bus when I was going to school. So often I waited for a bus for 15 minutes, and I didn't know whether the bus was coming or not. At that time, there were no mobile phones yet, so I couldn't check my mobile application to see if the bus was late and how late this was. And this is what the bus companies are trying to do. So they're trying to bring more value, bring more information to the customer who are using the transportation mechanism in order to have a better customer service. So knowing that you have to wait only 2 minutes is much better than knowing that you may have to wait for 2 minutes, for 20 minutes, or for 2 hours. So this is quite an old picture, but it's still relevant. It's still somewhat relevant, I would say. But when I started, and the first 2 years of my job or of my work, was I proclaimed big data to companies. And often you had to explain what is big data and how can you use it to bring better business value. The question was often, or the expectation was often, now I have this huge load of data. I have Twitter data, I have other social media, I have sensor data, log data, and so on. I'll just dump it on a Hadoop cluster and I'll start deriving value out of it. And that is not true, of course. You have to bring in smart people, you have to know which data you want to keep, which data you want to lose, which data is of value and which data is of no value. But first of all, you need to start with the business problem. You need to find what is really the business value that I want to derive? What is the potential value for the business? So just high volume by itself doesn't solve your problem. So how do you start? The best way is to start with your people. And the trend that I see in many organizations is that managers, but also CEOs, CIOs, and that they are starting to be more data savvy or analytics savvy. We see that business organizations or business departments such as customer service, financials and so on, they're starting to work with more data sets, they have more curiosity when it comes to exploring the data, and that is a good trend. Just having data exploration kept to IT is not a wise decision. I think it is important that the exploration of the data and the curiosity to the contents of the data needs to spread across the entire organization. That does mean that you will have a lot of initiatives that go beyond IT. So that is often a sort of a mismatch. IT wants to keep control over the data. They want to know where the data is stored, who is responsible for the data, and so on. Yet you have business users who are demanding to get insight into the data and to derive their own value. And leading a data-driven organization, so establishing a chief data officer is really important there. The question there is often, what if I could? So always ask yourself why. With every step that you're taking, with every project that you are embarking on, ask yourself the question, why am I doing this? What is the business value out of it? How can I explain this to my business users? And how can I use my existing infrastructure and my future infrastructure in order to derive that value? So this takes a couple of roles. First of all, the CDO I already discussed. I discussed the business users, and often you also need a data scientist. Finding a data scientist is almost the same as finding a unicorn. So finding one person who knows analytics, who knows deep math, who understands the business and can also communicate. If you have them, bring them to me, because we are hiring, really. It's really difficult to find a true data scientist. But if you can establish a data-savvy organization, so if your users are starting to be more informed about the data and how they can analyze the data, you will derive value out of it without having those key data scientists working for you. The other question you need to ask yourself is, where am I at this moment? Where is my organization at this moment? So a lot of it, and this is also IT-driven, of course, the infrastructure has mainly been driven by IT, and that is perfect, because they best know how infrastructure works, how to bring down the cost, and so on. So a lot of it has been about lowering the cost of storage. Hadoop is a good example for that. So instead of having those very expensive data warehouses, you can extend your data warehouses by bringing in Hadoop for the cold data, or for the staging, or maybe even for the analysis of unstructured data. That leads to data warehouse modernization. So that's a journey that a lot of customers have already embarked on. They have huge data warehouses from several vendors and so on, and they need to find ways of how to store the old data, how to offload the old data for a queryable archive. And that in itself is all positive, but it's still very IT-driven. It's not really analytics-driven. It doesn't really bring business value other than a bit of cost reduction. So most companies are now between that data is still in the data warehouse and also spread across the organization, and business users are starting to apply analytics, even advanced analytics. They're starting to use concepts like Spark, like R, like other analytics tools to make informed decisions. So, but that expands to full data set analysis. If you have all that data available, if you don't have to sample anymore, if you don't have to deliver small pieces of data to your end users to do the analytics, that brings real value to the organization, because your business users can then safely use the data that is stored in a Hadoop platform, in some other data warehouse, to run the analytics across an entire data set. So when you start building your models and so on, when you start testing your models and so on, having this large data set is extremely important. So finally, and that's a journey that that most companies are embarking on, is you want to drive new business imperatives. So if you think about your the gas consumption or the heat in your house, how has this been driven over the past 20 years? You had your supplier company that would deliver the gas, you would heat your house and so on, you would use your thermostat to control the temperature in your rooms, and you would see your monthly bill, or you would see a bill once per year where you would have the information from the past year. You could say, well, I need to lower my temperature in the weekend and so on, but it was really difficult to analyze the data because you didn't have all the detailed data available. Now we have thermostats that are smart. So you have Google Nest, you have, in my country, you have a thermostat that's called Tone, where you will be able to control the temperature in every room, and it will know where you are, it will know where you will be, pretty scary, I would say. It will know when you come home, so it knows when to heat up the house and when to lower the temperature again. So you see that analytics is more pervasive now. So it is not centrally controlled anymore like it was before, and you see that in organizations as well. But you see that analytics is everywhere, or analytics is going to be everywhere. And I think that building that model, or building your analytics or your drivers on the very large sets of data that you may have as an organization, will eventually help that to spread it out across the organization and make the business units also perform better. So I told you that I was going to tell you some lessons learned. So one of the things that you should definitely do is experiment. You have new technologies available. You have Spark, you have MLlib, you have Flink, you have some other, you have Hadoop still. And what you want to do is you want to give access to the data sets by certain users who can then explore, who can then derive new insights from the data. So if you allow your people to experiment on these large volumes of data and take small risks, your company will grow, and they will grow as well. I mean, in my journey as a programmer, and I've programmed in a number of languages, including COBOL, so that explains how old I am. But what I typically do is I try a language and I fail, and I learn by failure. And I think the same works when you start to explore your data. You start to derive insights, you try to find correlations and so on. And when finding those correlations, or while finding those correlations, you will fail because the correlations don't make sense, and you are told by the business user. But you will learn, and that's really important. So if you ignite a practice in your organization that will allow people to learn, that will allow people to experiment, your organization as a whole will grow. And maybe you will find those data scientists again. They may not be in the IT department or in the business intelligence department, but they may be hidden in the business department. So having people experiment is extremely important. The other thing that helps is don't position experiment to the people who provide the money. Position science. Because you will get the money easier when you position science than when you position experiment. So this is an example of where the customer experimented. This is a Swiss bank, and many of you know probably the story about 5 years ago. Somebody took 24,000 customer information data from the systems and sold it off to the French and to the German and to the US government. So they were all ducking tax. So preventing that theft of data became a regulation from the FINMA. And if you look at how many customer systems actually have customer identifiable data, such as account information, such as addresses, names, what have you. Even the emails that I send to my bank may be in some kind of system. So how do you protect all of those systems? Because your business users must have access to the systems. When a customer calls, you need to be able to find out what the current balance is. If a customer calls, you need to be able to find what the money transfer, where it went to, and so on. So you have a lot of people that use those business systems. So instead of trying to change all of those customer information systems, they decided to tap the network. So tapping the network from the customer domain or from the many customer domains that they have allows them to give insight or to get insight into what kind of customer data is transported over the network. So really talking about extremely high volumes of data, terabytes per hour, that need to be analyzed. And it's also not a simple analysis because, first of all, you need to decrypt the data, then you need to find out if there's any customer identifiable data in it. So is there an amount in it? Is there a name in it? Is there an address in it? So that requires a bit of text analytics. So being able to do that, being able to tap the network and to find out if somebody is actively using the data is already extremely important. But that in itself is not the solution because you have thousands of thousands of account managers who constantly look at that customer data. But then, if an account manager is looking at the customer data at 2 a.m., is that normal behavior? If that customer manager is deriving information from 100 customers per hour, that is probably also not normal behavior. And that is what they are trying to detect. They try to detect outliers. So again, this is a different approach. So rather than looking at the source systems, they looked at a different approach that they could address. And by using real-time analytics, they were able to do that. The other comment that I have is big data has often still been an IT initiative. And when you have an IT initiative, we're typically talking about storage, about servers, about memory, about processing power, what kind of data it is, and so on. We forget about the business value. So how do you make sure that you have a successful big data project? First of all, you need to involve the business users. You need to sell it to them. They don't care about whether we have a 4 terabyte drive or a 6 terabyte drive. They care about, is this going to bring me money? Is this going to bring me value? So the funding typically doesn't come from IT. The funding typically comes from a project that will derive a return on investment. So data warehouse modernization in itself can bring some value, but it is not new value, it's just cost reduction. If you want to bring value, you have to talk to the business users, so you have to involve everyone. Really, and this is, you have to promote everyone, so don't limit yourself to the IT department, don't limit yourself to one business department only. Make sure that you sell to everyone in the organization. So, as an example, the ability to detect 4 million of fraud is much more important to a business department than modernizing your data warehouse. So this is a trading bank that we talked to. We were contacted by IT. So the trading bank has a website where you can self-trade your positions and so on, so you can sell and buy. And they had a couple of issues with that. First of all, they had a lot of web logs. And the web logs, they were a couple of terabytes per day again. And they wanted to do root cause analysis. So if one of the web servers died or if one of the web applications died, they wanted to find out what is the root cause of this. And having many web servers didn't make that problem easier. Also, they had to throw away the data, the logs, after a couple of days. So they weren't able to store the logs for historic analysis. So it started with an IT problem. They wanted to keep all the logs and they wanted to be able to query the logs. But that in itself is just a cost reduction issue as far as I'm concerned. The second issue is when we started to involve the marketing department. Because when we talked to them, they said, well, we know which shares our customers buy. We know which shares our customers sell. But we don't know what their interest is. So if they hover over a certain position or if they have looked at a certain position, they may not have bought or sold, but they may have just shown interest. So having those web logs available will give them the ability to do microsegmentation, to have a better understanding of what drives their customer. They will be able to give recommendations to their customers. So then what you see is that this big data project, or in this case it was a Hadoop project, it started to evolve in something that was supported by multiple departments of the organization, not just the IT department, but also the marketing department. And you could find many other departments that would that would have a value out of it. So again, it is looking outside of the box, involving other departments about the technology, but also about the value that you can derive out of the information that you're gathering, is again extremely important. So where do you start first? Projects that take a year to implement are typically not successful. So if you do a proof of concept, if you want to prove business value, and this is your first project, and it takes a year for that project to start to bring value, that may not be the best project that you want to start with. So look for low-hanging fruit. Look for optimizations that you can apply that will bring immediate value. And sometimes that value may be small, and sometimes you may start with a smaller project. But if you start with a smaller project, that project will be the marketing campaign for the future projects to follow. And again, start small, think big. So this is an example of a oil drilling company. It's a European oil drilling company. There are not many, so you may be able to think which one it is. They drill off the coast of Norway. And what they do is they have to stop drilling every year in March, and they can resume drilling in October. And why is that? Because between March and October, there's an endangered species called the salmon. They are spawning. So they are spawning between March and October. When exactly? People don't know. So how do you know when the fish is spawning? Is by applying analytics to the data that you can derive. So having sound sensors, having sound or recording the sound and trying to analyze when the cod is spawning will give you value, or will give you information about when to drill and when not to drill. So they have been able to find additional periods where they can start drilling, where they can continue to drill without bringing danger to the environment. The other one is, so that was to secure the license to drill and to increase productivity. The other one is when you pump up oil, what companies typically do if it is subsea, they inject water into the wells. So the well is not usually one big container, it is usually several containers that are in a certain area. Sometimes they are connected, sometimes they're not connected. So when you drill the water or when you pump the water into the well, suddenly you can have an increase of injectivity. If you have an increase of injectivity, it could mean two things. The first one is a leak. The second one is your well suddenly starts to talk to another well. So how do you detect the difference between those two issues? The first one is an issue, the second one isn't an issue, it's actually an opportunity. So if you can have multiple sensors, if you're drilling in multiple wells, by combining information from the two injection pumps, you will be able to see if it is a leakage or whether that was just two wells being connected. So having that information in real time will also be able to shut down the processing or shut down the drilling if it turns out to be a leak. So very rapidly, with minimal damage to the environment. Very often, when you embark on a big data project, so we have seen companies who have gathered loads and loads of data. They are running 50,000 jobs, 50,000 MapReduce jobs, or 50,000 analytics jobs per day. And they came and talked to us, and they said, well, we're quite successful, but we have no idea what is in our cluster. We are loading the data every day, multiple times, for different purposes. So having the information available in your cluster in itself is not a good solution. Think about data governance as well. There's at least one person in this room who can talk about data governance. I will not name him. He's on the third row. But when you think about, when you start to establish your very large volumes of data and your different data sets and so on, also think about how will you make this data available to your end users? How will you make the data available to your business users and that they will trust the data? So the first one that you have to think about is cataloging the data. If you have a catalog of data where you can see when it has been loaded, who has loaded this, who's the owner of the data, what is the quality of the data, can I trust the data, yes or no, in which data source, in which analytics is this data used. That is one of the things that you have to think about. So you may not want to think about it when you embark on your experiment, but you may want to think about it when you envision the future. So when you think further, when you think about how will I eventually monetize my project, think about when you store the data, how can I make sure that the business users can find it, that the data scientists can find it, and that the end users will believe the results that they see in their analytics. So here are a couple of examples for lessons learned. So first of all, whenever we embarked on a project, obtaining the data, it takes time. So sometimes we get told, oh, in 2 weeks we'll have the data. Very often it's 2 months. Sometimes we're still waiting for the data for a couple of years. So make sure that you proclaim your project to the people who can deliver the data, who have the authorization to deliver the data in what shape or form, whether it is encoded or whether it is masked or something like that, but at least you will be able to have the data. The other one is when you are talking to or when you are embarking on a project, make sure that you still keep in mind that you're addressing a business problem. If at the end of the project, if you have value, for example, you are decreasing the storage, or you suddenly have a lot of more log data available for your analysis and so on, translate this into a business problem that has a value to it. If you can translate it to a business value that has a value to it, or a business, if you can translate it to some kind of money value, you will more easily get funding for the next part of your project. The other one is when we've been in projects where the users or the companies just said, well, here you have a terabyte worth of data. Try to find some correlations. Great, I love it. You know, you have this whole big data set, you have this huge cluster where you can apply your math, you can build your models and so on, and you will find correlations. Really, you will find correlations. Are they useful? Not at all. So when you work with your business users, you're not wasting your time anymore. You may not be able to find the best correlations, but at least you'll avoid spurious correlations. And you'll also avoid correlations that are trivial. For example, small children with bigger feet are better readers. That's a trivial correlation. And why is that a trivial correlation? Well, usually a kid that is 5 years old has bigger feet than a kid that is 3 years old. So it's an obvious correlation. You'll be able to draw that correlation, but it's trivial. And we have been in a number of projects where we have gotten this huge load of data and we have been able to find correlations. And then you start talking to the business users and they said, yeah, we've known this for a number of years already. You didn't have to tell us. So business users are extremely important. And if you don't have your data scientist who knows the business, at least work with the business users. So form your data scientist with a business user and a mathematician. And the other one I already taught, envision the future. So don't think that your project stops when you have proven the value and you have finished your experiment. So finally, when you embark on your data-driven organization, there's a number of steps that you have to go through. And so first of all, you have to transform yourself. You have to transform your company to a data-driven culture. So you have to think about analytics everywhere. You have to provide the data to the customers. You have to provide the data to the end users who will be able to run the analytics if they're data savvy. The second one is you want to scale. So you want to scale your experiment by thinking about additional use cases. So the example of the trading bank, where we initially had the problem of analyzing the log data to find the root cause or to do the root cause analysis, you expand the use case by something that is useful for marketing. So again, think beyond the box and think about other uses of your data. So eventually you'll have a path where you will eventually end up with identifying the high-value opportunities. So you will eventually, by running this practice, by making sure that your end users have access to by ensuring that your business users have access to the data and they can run their own analytics, you will spread out the analytics nature of your organization, and your organization in itself will be more successful. So this is my final thought. Please seize the moment. And we're all here together, and we have seen fantastic technologies. We have seen great examples of where customers have driven value out of the data, where they have used the technology that is at their disposal to bring new value to their business. And let's go and hunt them. Thank you very much.